Hello students. So in the previous video, we saw what is a circle and we discussed some important terms related to circles like chord, secant, tangent and segment, sector, all those stuff. And in this chapter, as I told you, we are going to discuss more about tangents. So what is a tangent? It is simply a line which meets the circle at only one point. That's it, on and only one point. If a line meets at 2 points on the circle, then it is called a secant. Only 1 point, tangent. 2 points, it is secant. Okay. And we discuss some important properties of tangents. That is, the angle between the radius and the tangent at the point of contact will be 90 degrees. Okay. And from an external point, that is a point outside the circle, from that point you can draw two tangents and both the tangents will be equal in length. These are the things that we have discussed so far. Okay. Now let's start with our exercise. Okay. So the first exercise on tangents, okay, on circles. The first question of the first exercise: how many tangents can a circle have? Okay, how many tangents can a circle have? Very simple. How many points can you have in a circle? Think about it. How many points can you have on a circle? Can you count it? No, right? The point itself is not defined. Okay, it's a very primitive word. Okay, so you can draw many tangents as much as you like, because on a circle there are infinite points, isn't it? There are so many points on the circle, which means you can draw for each point you can draw a tangent. Okay. In the previous video I told you, if a point is on the circle you can draw one tangent to it. So how many points are there on the circle? There are many points, infinite points, beyond finite. Therefore you can draw many tangents to the circle. Therefore the answer will be infinite tangents. Okay. So how many tangents can a circle have? A circle can have infinite tangents. Okay. The next one, a tangent to a circle intersects it in dash points. How many points does the tangent intersect? The other word of intersect, we can say it as meet. How many points does it meet? It meets at only one point. Therefore, the answer is 1 point. Okay. Second question, a line intersecting a circle in 2 points is called as a line which meets the circle at 2 points is called as what? Secant. Very good. A circle can have dash parallel tangents at the most. A circle can have dash parallel tangents at the most. Okay. How many parallel tangents can it have? Okay. So let's discuss this. Now, say suppose you got a circle. Okay. Let's take a diameter. Okay. Why? Because these 2 points are exactly opposite. Okay. So let me take a diameter and we'll be doing this. Okay. If you draw tangents at the ends of the diameter, they'll be parallel. We are going to prove that. Okay. I repeat it. This is the diameter. If you draw a tangent at this end and this end, they'll be parallel to each other. Okay. So this is a proof that we are going to do later. Okay. So I can draw a tangent here and I can draw a tangent here. Okay. Isn't it? Similarly, the question is how many, at the most, how many tangents can you draw? It depends on how many diameters I can draw, isn't it? Suppose if I draw a diameter here, let's say P and Q, I can draw a tangent here, I can draw a tangent here. Similarly, if I take a diameter like this, I can draw, let's take this is M, this is N, I can draw a tangent here and I can draw a tangent here, which are parallel to each other. Similarly, you can keep doing this, isn't it? You can draw infinite diameters. You can draw infinite diameters. Therefore, it is infinite tangents which are parallel to each other. At the ends of the diameter, if I draw tangents, they'll be parallel to each other. Therefore, how many diameters can I draw? We can draw infinite diameters. Therefore, at the ends, if you start drawing the tangents, you can have infinite tangents which are parallel to each other. Okay. So that's the answer for the question. That is question number 3. A circle can have infinite parallel tangents at the most. The common point of a tangent, the common point of a tangent to a circle, and the circle is called as what? Simple, point of contact. The point which is the point where the tangent touches the circle, it is called as point of contact. Okay, let's start with the third one. A tangent PQ at a point P of circle of radius 5 centimeter. Okay, there is a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at the point Q, so that OQ equals 12 centimeter. Find the length of PQ. Okay, so let's do this. A tangent PQ. Let me stop sharing. Okay, so let's erase this and do it. Okay, so basically there is a circle. We know that, isn't it? There is a circle. This is first exercise 10.1 for state board students. Okay, but for CBSE the chapter number is different, but the exercise is the first exercise itself. Third question. So what is the question? We have got a circle. Let's take the center O. Always we take the center to be O. Okay, there is a point P. Okay, PQ is the tangent at a point P. Okay, so let me read out the question again. Let me share the question again. A tangent PQ. Okay, what is PQ? PQ is a tangent. Okay, at a point P. So where is the tangent drawn? At the point P of a circle. Okay, meets a line through the center O at a point Q, so that OQ equals 12 centimeters. Okay, find the length of PQ. Okay, by now you have got to know there is a tangent PQ. Okay, let's take this point as P. There is a tangent. Let's take like this. This is PQ, the tangent, and O and Q meets. Okay, O and Q meets. Okay, it's given in the question. Now let's join OP also. Okay, this is given as OQ is given as 12 centimeter. Okay, OP is radius of the circle, which is 5 centimeter. Okay, we must find the length of PQ. I hope this is clear. We had a circle with center O and PQ is tangent. Where is this P? This P is on the circle. Okay, because the tangent is drawn at P. It is given. Okay, so this is the tangent that is drawn at P. Okay, we are joining O and Q. This is 12 centimeter, 5 centimeter. We have to find PQ. Okay, so we'll use the property of the tangent. What is the property? This is radius and this is tangent. What is the angle? Angle is 90 degree. Angle OPQ is equal to 90 degree. Why? The reason is the tangent is perpendicular to the radius. Okay, so since it is a right angle triangle, we can use Pythagoras theorem, isn't it? What is Pythagoras theorem? In a right angle triangle, the square of hypotenuse is equal to sum of squares of other two sides. Now, which is the hypotenuse? The side opposite to 90 degree. Here we have got 90 degree, which is the side opposite to it? OQ. Okay, so let me write it. Using Pythagoras theorem, what do we get? OQ square is equal to OP square plus PQ square. Okay, it is always you have to start with the hypotenuse itself. Sometimes what happens is they'll give you this hypotenuse, the same problem. We have to find PQ. So most of you, what you do is you start with PQ. PQ square is equal to OP square plus OQ square. That is how you do it. Some of you. Okay, it is wrong. Okay, it doesn't depend which side I am finding. Don't worry about which side I am finding. You should always start with hypotenuse. Which is your hypotenuse? 90 degree opposite, OQ. Start with that itself. OQ square will be equal to OP square plus PQ square. Okay. Now, which are the values that I know? I know the value of OQ, that is 12 square. Do I know the value of OP? Yes, it is 5 square. Plus, do I know the value of PQ? No, I don't know. So I have to find it. Let's keep it as it is. Okay. Now, what does 12 square? 12 square is 144. Okay, let me write it here. 12 square is equal to 144. Okay. Next, 5 square is 25 plus PQ square. Get this 25 this side. 144 minus 25 is equal to PQ square. I need this. I don't want it. Send it the other side. Okay. 144 minus 25. So you get how much? 190. Isn't it? Yeah, 119 equal to PQ square. Therefore, you need PQ, right? Send the square to the other side. It will become root. Okay. Root of 119 is equal to PQ. What is the value of PQ? Square root of 119. Basically, you would have learned whenever you're taking a square root, you should put plus or minus, right? For example, if it is like this, x square is equal to 25, then x is equal to plus or minus root 25. Isn't it? Why? The meaning of this is, if I ask you the square root of 25, which number should I multiply by itself to get 25? So the answer will be 5, because 5 into 5 is 25. Similarly, minus 5 into minus 5 is also 25. Therefore, whenever you put square root, we have to take plus or minus. But why are we not taking here? Because this PQ is a length. Okay, length cannot be negative. It is always a positive value. That is why we don't take the negative into consideration. But if it is somewhere else, you have to take this both plus and minus into consideration. Okay, so what is the value of PQ that we got? It is root 119. So from this problem, we got to know that we are going to get a right angle triangle and we can use Pythagoras theorem. Most of the problems deal such kind of things where you get a right angle. How do you get a right angle? Because the radius and the tangent are perpendicular to each other. You get a right angle. We are going to use Pythagoras theorem. Okay. So let's get into the next problem, students. So the option D, isn't it? Square root of 119 centimeter. That will be the correct answer. Okay. Next question. Draw a circle and two lines parallel to a given line. Okay. Draw a circle and two lines parallel to a given line such that one is a tangent and other one the secant to the circle. Okay. So we have to draw a circle. Okay. Then we have to draw two lines. Okay. Parallel to a given line. Okay. There is a line which is already given. Okay. Then we have to draw two lines parallel to this given line in such a way that one is acting as a tangent, other one is acting as a secant. Okay. So let's do it. Let me share the whiteboard and let's do this. Okay. Once again. So let's take a circle. Okay. As you can see, I have taken a circle. Okay. Then first we have to draw a line, isn't it? Let's say this is the line that is already given. Okay. This line is already given. Okay. Now we have got a circle. We have got a line, which this is already given. Okay. Now I have to draw two lines. One line should be tangent to the circle. Other line should be secant to the circle. What is secant? Secant is a line which intersects circle at 2 points. Okay. Something like this. Okay. This is our secant. And remember, this secant and the line should be parallel. Okay. That is why I have drawn it like this. Okay. The other one I have to draw a tangent. Okay. Let's draw a tangent which touches the circle at only 1 point. Okay. I've just drawn a rough diagram. Okay. This is not parallel. Let's make it parallel. Okay. So let's start from here. Okay. Something like this. Yeah, that is fine. That is exactly fine. Okay. So we had already a line. Okay. To that line, we had to draw two parallel lines. We have drawn it. One is, if you observe, one is acting as a tangent. The other one is acting as a secant. Okay. So this is the answer for the last question of this exercise. Okay, so let's get into the next exercise. Second exercise, a very important one. Okay, so before getting into the second exercise, I repeat it again. In most of the problems, okay, we are going to get a right angle triangle. How do we get this right angle? The property, that is the tangent and the radius are perpendicular to each other. Whenever you get a right angle triangle, we are going to make use of Pythagoras theorem. Okay, students, let's get into the next exercise. Okay, students, now I've shared the screen. So in this second exercise, the first question, from a point Q, okay, there is a point Q, okay, the length of the tangent to a circle is 24 centimeter. From a point Q, the length of the tangent, meaning from this point Q, we have drawn a tangent to the circle and the length of the tangent is 24 centimeter. Okay. The distance of Q from the center is 25 centimeter. Find the radius of the circle. Okay. A very simple question. So there is a point Q and obviously there is a circle with center O. Remember, it is with center O. Okay, from this point we have drawn a tangent. Okay, let me draw it properly. From this point we have drawn a tangent. Let's say this point has some P. That will be fine. And the length of this tangent is, this is tangent, right? Because it is meeting the circle at only one point. The length of the tangent is 24 centimeter. And the distance of this Q from the center, meaning this distance is 25 centimeter. We have to find the radius. Just join OP. OP is the radius, isn't it? We have to find the value of this. As I told you, we have to make use of the property. What is the property? The radius is perpendicular to the tangent. So this is the radius that we have got. This is the tangent. So what is the angle between them? 90 degrees. So angle OPQ is equal to 90 degrees. What is the reason? The tangent is perpendicular to the radius. So we got it. The tangent is perpendicular to the radius. Now we have got 90 degrees. What type of triangle now it is? Right angle triangle. What can I use? Pythagoras theorem. So let's use Pythagoras theorem. Using Pythagoras theorem. What can I write? We should always start with hypotenuse. Remember, which is our hypotenuse? Opposite to 90 degrees. Okay. And one more mistake that students do is, okay, I know it is here, it seems like you have got 90 degree. Here, it seems as if there is a 90 degree. Remember, until unless you don't mention this sign like this, you cannot conclude as 90 degree. If you want to say it as 90 degree, you have to put the sign like this, the symbol like this. Okay. Now here it is 90 degree, which is the hypotenuse? 90 degree opposite, that is OQ. So OQ is the hypotenuse. OQ square is equal to the remaining two, OP square plus PQ square. Okay. Now let's substitute. OQ value is known. How much it is? 25 square. OP value, we have to find it. PQ value is known. 24 square. Okay. So let's get into the next step. What do we do in the next step? 25 square is 625 equals OP square. We'll keep it as it is. 24 square is 576. I need this fellow. I don't need this fellow. So send him the other side. This is like a compound. Put him the other side. Okay, 625 plus 576. This side will become minus 576 equal to OP square. So 625 minus 576 is 49 equals OP square. Okay. Therefore, what will OP become? Square root of 49. Isn't it? If the square goes the other side, it will become root. And remember one thing, OP is a length. That is why we are not taking plus or minus. Okay. Otherwise, in other chapters, we have to take it. Okay. So square root of 49 is 7. Therefore, OP is equal to 7 centimeter. What is OP? OP is the radius of the circle. Therefore, what is the radius of this circle? That was the question, right? The radius of this circle is 7 centimeter. Okay. So let's get into the next problem, students. Second question. Okay. So in the figure, if TP and TQ are the two tangents, okay, they have given us the figure 10.11. Okay. So in the figure, TP and TQ, as you can see, TP and TQ are two tangents drawn from an external point. Okay. The angle POQ equals 110 degrees. What is the angle PTQ? Angle PTQ should be found. Okay. So it's a very, very easy question. So let's do that. So what we have got a circle. We have got a circle with center O. Okay. So we have got 2 points P and Q. This is P, this is Q. From here, we have got a tangent. From here, you got a tangent T, P, T, Q. Okay. So here the angle is 110 degrees. What is the angle here? P, T, Q. That's what we have to find. A very easy one. So basically, if you observe, it has got four sides: PT, TQ, OQ, OP. A four-sided figure. What do you call a four-sided closed figure? As quadrilateral. So this is a quadrilateral. Okay. Now observe, this is radius. OP is radius. What is radius? From the center, if you connect any point on the circle, it is radius. It is like the spokes of the wheel. Okay. Have you observed a wheel and the spokes in it? It starts from the center, goes, this is like the spokes. You will have like this, right? So these are like radius. Okay. So that is radius. The angle between the radius and the tangent is how much? 90 degree. Okay. So here it is 90 degrees. Similarly, here it is 90 degree. Okay. So let's write that. Why? What is the reason? Angle OPQ is equal to angle, not OPQ, OPT. I'm sorry. Angle OPT and OQT both are equal to 90 degrees. Because the tangent is perpendicular to the radius. Okay, since the tangent is perpendicular to the radius, we get it. Okay. Now in quadrilateral, it has four sides, right? Four-sided closed figure. In quadrilateral, OPTQ, in this quadrilateral, if I add all the four angles, angle O plus angle P plus angle Q plus angle T, it is equal to 360 degree, isn't it? Because it is known as what? Angle sum property of quadrilateral, ASP. Angle sum property of quadrilaterals. In quadrilaterals, there are four angles. If you add everything, you get 360. What is O? 110. What is P? 90. What is Q? 90 degrees. What is T? We have to find it. Equal to 360 degrees. So 110 plus 90 is 200. 200 plus 90 is 290. 290 degrees plus angle T equals 360. Therefore, angle T will become 360 minus 290, which will give you 70 degrees. Angle T will be equal to 70 degrees. Okay. And one more thing, from this, we can conclude the angle between the tangents and the angle formed at the center are supplementary to each other. Just observe, this is 110. Here you got it as 70. 110 plus 70 is how much? 180. Okay, we are going to prove this. In general, I cannot say, just using this one example, I cannot conclude that if I had this angle and this angle, I'll get 180. Okay, that is very wrong. Okay, in some other example, maybe here it might be 100 and here it might be 120. You get if you add 220. Okay, but you won't get it like that, because there is a theorem itself which states that the angle at the center and the angle between the tangent are supplementary. Very simple, because these two are 90 and 90, right? So 90 plus 90 is 180. So this and this should give you 180 on the whole, so that you get 360 degrees, because it's a quadrilateral. If this and this gives you 180, this and this should give you 180. That's the logic. We are going to prove this very soon. We are going to prove this in general. Okay. So let's get into the next question, the third one. Tangents PA and PB from a point P. Okay. There is a point P. From that, we have drawn two tangents, that is PA and PB. to a circle with center O, and they are inclined to each other, meaning the angle between PA and PB is 80 degrees. What is the angle POA? That is what we have to find. Okay, very simple. We have got a circle. We have got a circle with center O, and there is a point P. From this point P, we have two tangents. One is PA, another one is PB. Okay, these are the two tangents. The angle between them is 180 degrees. 80 degrees, 80 degrees. Okay, we have to find angle POA. Okay, let me join it. POA. So this angle POA is this one. Okay, question mark. Let me also join this. Okay. Now, in the theorem, we have already proved. This is what we had in the theorem, right? Same type of figure. Okay. And we very well know that here we get 90 degrees. Here we get 90 degrees because the radius and tangent are perpendicular to each other. Now, we have already proved in the theorem that these two triangles are congruent using RHS theorem. I'll repeat it again. What is RHS theorem? First, both the triangles should be right angle. You should have right angle. What is there? R. What is H? Hypotenuse should be equal. In both the triangles, the hypotenuse should be equal. What is the hypotenuse of this triangle? OP. What is the hypotenuse of this triangle? OP. So both are same, which means both are equal. Okay. R, H. Then is S. What is S? Any one side in both the triangles should be equal. So OA in this triangle, OB in this triangle are equal because both are radius of the same circle. Therefore, using RHS theorem, these two triangles are congruent. Okay. Triangle OAP is congruent to triangle OBP using RHS. If they are congruent, the corresponding angles, that is the remaining parts of the triangle. Okay. The remaining parts is like which things which I have not discussed. Did I discuss about this angle and this angle and this triangle? No. Or this and this, that is APO, BPO angle? No. So they will be equal. Okay. That is CPCP, right? Now, it's a small confusion. Will this angle and this angle be equal, or this will be equal to this? How do I get it? Very simple. You take equal sides. What I'm trying to say is, okay, I cannot simply conclude this and this will be equal, this and this will be equal. That's not correct. I should have enough proof that this and this will be equal. Why not this can be equal to this? Let's name it for our purpose 1, 2, and let's take this as 3 and 4. How can I conclude 1 is equal to 2 and 3 is equal to 4? Why not like this? 1 is equal to 4, 3 is equal to 2. Why not like that? Or how do I know 1 is equal to 2? Very simple. Okay. You take equal sides, their opposites will be equal. Okay. So we know that PA and PB are equal, right? That's what we proved, right? PA and PB are equal. What is the opposite angle of PA1? What is the opposite angle of PB2? PA and PB are equal. Their opposites are also equal. So 1 and 2 are equal. Similarly, OA and OB are equal. What is opposite of OA? 3. What is opposite of OB? 4. They are equal. Okay. Implies what is the name of this angle? OAP is equal to not OAP. It is AOP is equal to BOP. Similarly, these two, APO is equal to BPO, CPC. Now, if these two angles are equal, the complete angle is 80. If these two are equal, it becomes 40, right? This becomes 40, isn't it? Because these two are equal. Equal in the sense both should become 40 and 40, so that the total angle is 80. Okay, which implies what is the name of this angle? APO. APO is half of the complete angle. What is the complete angle name? APB. That is half into 80 degrees will become 40 degrees. Okay, we got the value of APO. Now concentrate on this triangle, APO triangle. in triangle APO, let me add all the angles. That is angle APO plus POA plus PAO. All the angles, if I add all the three angles in a triangle, it will be equal to 180. APO is 40. Just now we did it. POA, we have to find it. PAO is 90 because at A it is 90 degrees, equal to 180. Therefore, PAO plus 90 plus 40 is 130, equal to 180. Therefore, POA is equal to 180 minus 30. Therefore, POA is equal to 50 degrees. Okay. So we got this angle 1 as how much? 50 degrees. If angle 1 is 50 degree, what about angle 2? Think. It is also 50 degrees because these two angles are equal, isn't it? That's what we have proved using CPCP. So these two are equal. So if this is 50, this will also become 50. So total will become 100. Here it was 80. So half of 100, half of means 40 and 40. Okay. So this is the third question. So let's get into the next question, students. Fourth one. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. This is what I said in the first exercise, right? We are going to prove it. So let's prove it. So the tangents drawn at the ends of the diameter. So this is fourth question. So we have got a circle. Okay. Circle with center O. Now we should draw a diameter because the tangents drawn at the diameter, at the ends of diameter. That's the question, right? So let's take a diameter. Diameter is the chord which passes through the center of the circle, isn't it? So let's take this as A and let's take this as B. Okay. Now what are we doing? Very simple. We are going to draw two tangents where at the ends of the diameter. So this is the diameter. This is one end. This is the other end. Let's draw tangents. Okay. Let's draw one tangent here. Okay. And let's name it as XY. So XY is a tangent. The other one is, let's take PQ as the other tangent. PQ is another tangent. Okay. So what is given basically, they have given us diameter and the tangent to a circle, right? So let's write it. PQ and XY are the two tangents, isn't it? These are the two tangents drawn at the ends of diameter AB of the circle with center O. You should always mention the circle with its center. Okay. So this is given. What should we prove? We have to prove these two tangents are parallel to each other. That's it. So to prove XY is parallel to PQ. This is what we have to prove. Very simple. Let's get into the proof. Very, very easy. Now, angle PAO is equal to how much? Angle PAO, this angle is equal to how much? Think about it. Very simple. We have got only two properties. We have to use only those two properties. One property is the angle between the tangent and the radius. How much it is? 90. It is 90 degree. Similarly, what about this angle? Okay. Angle OBX or XBO. That is also 90 degree. Same concept. What is the concept? The tangent is perpendicular to the radius. This is the only property that we are using again and again. Okay. Now observe, aren't these angles alternate angles? How do you identify alternate angles? Z shape. Observe carefully. You're getting a Z shape. The angles which are in Z shape, okay, so those angles are called as alternate angles. And if alternate angles are equal, remember one thing, it is not necessary that alternate angles will always be equal. Okay, most of you have this perception that whenever it is an alternate angle, it will be equal. No. Alternate angles, how do you identify? Z shape. They need not be equal. If they are equal, then the lines are parallel. If they are not equal, the lines are not parallel. Let the lines be parallel or not parallel. Don't bother about it. Z shape, alternate angles. Okay. If alternate angles are equal, lines are parallel. The vice versa. If lines are parallel, alternate angles are equal. Now these two angles, this is also 90, this is also 90, and these two are alternate angles. Therefore, they are equal. Alternate angles are equal. If alternate angles are equal, lines are parallel. Okay. Angle POA and angle XBO are alternate angles. Therefore, XY is parallel to PQ. You can write it. Okay. If alternate angles are equal, then lines are parallel. You can take it. Okay. If alternate angles are equal, then the lines are parallel. This is the question. This is what we had. How many parallel tangents can you draw? This tangent and this tangent is parallel because they are drawn at the ends of the diameter. How many diameters can you draw? Many diameters. Therefore, you can draw many tangents which are parallel to each other. Okay. So this is the answer for the fourth question. So let's get into the fifth question. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay. Let's analyze this question first. Okay, we have to prove. What should we prove? The perpendicular at the point of contact. Okay, we have drawn a perpendicular at the point of contact, passes through the center. Okay, this is what we have to prove. Let's draw the figure and let's understand it. We have got a circle. With center O. And let's consider a tangent. What is a tangent? Which meets the circle at only one point. Okay. This is P. Okay. Now I'm drawing a perpendicular here. Okay. Now if I extend, I have to prove it passes through O. If I extend this line, suppose this is the perpendicular that I have drawn. If I extend this line, I have to show that it passes through the center itself. It's not going to go through any other point. That's what we have to prove. Okay. Let's do it. Okay. We do this. We solve this answer by something called as contradiction method. What is this contradiction method? We initially assume something. Okay. We initially assume something and we start solving. As and then we solve, okay, we get an answer which is exactly opposite to the assumption. That is, it is the contradicting the assumption. Okay, I would have started saying this is true. Okay, something is true. Okay, let's say an apple is green in color, or let's say an apple is orange in color. I'm just giving an example. Okay, now I'll start solving whatever the proof, but then I'll get to a point where I get an answer like this. Initially, I started with an apple is orange in color. Okay. Then I was doing the theorem, all those stuff, solving. Then I ended up with a statement saying, therefore, the apple is red in color. But what was my assumption? My assumption was I assumed apple is orange in color. But where did I end? I ended at the point apple is red in color. It is exactly opposite to my assumption, isn't it? This type of things are called as contradiction method. You assume something and you solve it, you end up an answer where you are contradicting your original assumption. This is known as contradiction method. Okay, so I'm going to solve it. Okay, here I'm going to make an assumption. What is the assumption? Let us assume that this perpendicular is not going through O. It's not going through center. It is going through some other point. Let's take that some other point as some, let's take it as M. Okay, let's take it as M. Remember, we are assuming that this perpendicular this perpendicular is going through M. Okay, let's assume like this. Okay, let us assume the perpendicular, where is this perpendicular drawn? At the point of contact, isn't it? The perpendicular drawn at the point of contact P, at the point of contact P, doesn't pass through O, instead passes through point M. Is this M the center of the circle? No, this is not the center of the circle, very clearly. Okay, now I have assumed that this is the perpendicular that it is passing through M. If it is perpendicular, what is this? MPY. What will be the angle? I have assumed this to be the perpendicular. Okay, assume it that this line is perpendicular to this. Okay, so implies angle MPY is equal to 90 degrees. But we already know that OP is the radius and this is tangent. Angle between radius and tangent is 90 degrees. Let me also conclude. Angle OPY is equal to 90 degrees because tangent, this we have learned it, right? Tangent is perpendicular to the radius. We have learned this, so I am using it. Therefore, observe, both are equal to 90 degrees. Therefore, I can tell angle MPY is equal to angle OPY, which implies angle MPY is equal to OPY. But observe the figure. Angle OPY is this entire thing. Angle MPY is only so much. Can these two be equal? Is it possible? Very clearly, they are not equal. But what are we getting? We are getting the answer, it is equal. We have got the answer as equal. But from the figure, clearly from the figure, angle MPY is not equal to angle OPY. Observe, we are getting equal. The other thing is saying not equal. Why are we getting this type of answer? Contradicting answers. Because initially we made an assumption. That is why we are getting like this. What is the assumption that we made? This perpendicular drawn here doesn't go through O, will go through some other point M. That is the assumption that we have made, right? That is wrong. That is how we get to know that is wrong. How did we get to know? Because through that assumption, we assumed something and we started solving. We got this. Through our assumption, we got this answer. But it is very clear that these two are not equal. Isn't it? These two are equal is what we got. But very clearly from the figure, are these two equal? No, they are not equal. This is wrong, right? This is wrong. This cannot be possible. Why is this cannot be possible? Because this cannot be possible. If this is possible, then this is possible. Isn't it? But this is not at all proper. This is not at all correct. This is wrong. If this is wrong, the assumption that I made is also wrong. Okay. Therefore, the perpendicular drawn at the point of contact passes through the center. That is the last thing that we have to write it here, which is a contradiction. Therefore, the perpendicular drawn passes through the center of the circle. Very simple. There is nothing to get confused, students. Very simple. We assume something, so we got this. Isn't it? We assumed something, we got this. But is this correct? No, it is wrong. This is wrong, right? Why is this? Why did we get this? We assumed this. If this is wrong, then this assumption is also wrong. That's it. Okay. So let's get into the next question. Sixth one. Length of a tangent from a point A at a distance 5 centimeter from the center of the circle is 4 centimeter. Find the radius of the circle. Very easy one. The length of the tangent from a point A. Okay, there is a point A at a distance of 5 centimeter from the center. So this point is at a distance of 5 centimeter from the center. And what is the length of the tangent? The length of the tangent is 4 centimeter. Find the radius of the circle. I'll just give you the hint. It is very easy. You can solve it by yourself because I've already done such type of problems. There is a circle with center O and there is a point A. From this point, I've drawn a tangent. Okay. Now this point is at what distance? At 5 centimeter distance from the center. And what is the length of the tangent? The length of the tangent is 4 centimeters. We have to find the radius of the circle. Let me take it as P. Here it is 90 degrees because radius and tangent are perpendicular to each other. We have to find this. Isn't it? We have already solved such type of problem. Okay. Use Pythagoras theorem. You'll get the answer. And the answer should be 3 centimeters. I'll give it as a task for you students. Try it because I've already solved such type of problem. This is 6th one. Okay. So let's get into the next question. 7th one. Concentric circles are of radii 5 centimeter and 3 centimeter. Okay. Find the length of the chord of the larger circle which touches the smaller circle. Now there are so many things. Let's recall. 2 concentric circles. What are concentric circles? Circles with same center but different radii. You will have the same center. You take a compass, draw a circle. Now with the same center, increase the radius, draw a circle. You keep doing it, you get concentric circles. Okay. Now find the length of the chord. Okay. We have to find the length of the chord. Okay. Of the larger circle. The length of the chord of the larger circle which touches the smaller circle. Okay. Very, very interesting question and a very important one. Let's take this is the center. First we are going to draw a circle with 3 centimeter radius. Again, let's take this as the center itself and draw another circle like this. Okay. So the smaller one is 3 centimeter radius. The bigger one is 4 centimeter radius. Okay. Now, find the length of the chord of the larger circle. Okay. There is a chord of the larger circle which is touching the smaller circle. Something like this. AB is the chord of the larger circle which is touching the smaller circle. Something like this. Let's take this as O. Okay. Let's join this O and A. OA is what? Radius of the bigger circle. That is 5 centimeters. Remember that. Okay. Let me take this point as P, the point of contact as P. Let me join this O and P. OP is what? The radius of the smaller circle. So this is 3 centimeters. Okay. Now, what should we find? We have to find the length of AP. Now, AB, okay, solution, AB is the chord of the larger circle whereas it is what? It is a tangent to the smaller circle. It is tangent to the smaller circle, isn't it? It is tangent to the smaller circle, which implies if this is a tangent, this is a radius, this is a tangent. What is the angle? 90 degree. Angle OPA is equal to 90 degrees because tangent is perpendicular to the radius. That is the reason. Okay. Now OPA equals 90 degrees. Now, very simple. You got a right angle triangle now. Use Pythagoras theorem. In triangle OAP, using which theorem? Pythagoras theorem. Okay, what does Pythagoras theorem tell you? The square of hypotenuse, which is our hypotenuse opposite to 90 degrees, that is OA. OA square is equal to OP square plus AP square. Okay, OA is 5. 5 square is equal to OP is 3 square plus AP square. So you get 25 equals 9 plus AP square. I want AP, send this 9 that side. 25 minus 9 is equal to AP square which implies 16 equals AP square. Therefore, AP equals square root of 16, which is 4 centimeter. Therefore, AP is 4 centimeters. Okay. Now, a very, very interesting property. Now, we got this length as 4 centimeter. If this is 4, this will also become 4. Why? Because what is this AB for the bigger circle? It is a chord. To the chord, if you draw a perpendicular from the center, this is the center. From the center, we have got a perpendicular. What happens to the chord? The chord gets bisected, isn't it? We have learned it as a property in our 9th standard that for a chord, if you draw a perpendicular, chord gets divided into 2 equal halves. That is what happening here. Okay, this is a perpendicular. How did it become perpendicular? Because it was tangent to the smaller circle. Since it is tangent to the smaller circle, you got 90 degrees. Now this is a perpendicular line. Therefore, this line is divided into 2 equal parts, AP and PB. If this is 4, this will also become 4. Okay. Therefore, AB is twice of AP. That is 2 into 4 equals 8 centimeters. Why? What is the reason? The perpendicular drawn to the chord, drawn from center to the chord, bisects it. Bisect in the sense divide into 2 equal parts. Okay, so very, very simple. We had 2 circles, concentric circles, same center, different radii. Okay, now this is acting as a chord for the bigger circle, whereas it is acting as a tangent for the smaller circle. Since it is acting as a tangent for the smaller circle, here you get 90 degrees. Using Pythagoras theorem, you got this as 4. If this is 4, this will become 4 because a perpendicular will divide a chord into 2 equal parts, 4 and 4. Okay, that's the answer for this question. So let's get into the next question, students. Quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD equals AD plus BC. You can see this figure, that is this figure. Okay, this is the figure that we are talking about. Okay, so let's erase it. I hope it's clear now. Now, once again, let me scroll a bit down. Here we have got a quadrilateral circumscribe a circle. What does that mean? Okay, it means if a quadrilateral, what is a quadrilateral? 4-sided closed figure, right? If a circle touches all the 4 sides of a quadrilateral, can you see it? It is touching all the 4 sides. Therefore, that circle is called as inscribed circle, or we call it as, in another way, a quadrilateral is circumscribing the circle. A quadrilateral is circumscribing the circle. Okay. So that is the meaning. A quadrilateral circumscribing in the circle, in the sense, it is simply a quadrilateral in which a circle is there, which is touching all the 4 sides. Okay, we have got like this a figure. We have to just prove AB plus CD equals AD plus BC. That's what we have to prove. Now, this question and the other question are almost similar. That is the 11th one. Prove that parallelogram circumscribing a circle. The other question was quadrilateral. Now, they have given a particular name. What is the particular name of this quadrilateral? It's parallelogram. Parallelogram is also quadrilateral, right? So we're going to solve this 8th one and 11th one at a time. Okay. So let's solve this first. A quadrilateral circumscribing a circle in which we have to prove AB plus CD equals AD plus BC. I mean the sum of opposite sides. AB and CD are opposite, add them. AD and BC are opposite sides, add them. Both will be equal. Okay. Now let's take a circle. Okay, with center O. I'm not going to draw the exact figure as in the textbook. I'll just randomly draw a quadrilateral. Okay. So something like this. Okay. Something like this. Okay. So A, B, C, D. If they have given the other name, that's okay, no problem. Okay, you can solve it according to the question that they have given. Okay, I have taken my own figure. Okay, A, B, C, D. See, observe this circle is touching all the four sides. Let's take these points as P, Q, and R and S. Forget about the figure, okay? Change it up. If you want, you can change the names. Doesn't matter, okay? Now, what should we prove? We have to prove that AB plus CD. AB is this, CD is this. That will be equal to AD plus BC. These two opposite sides you added, these two opposite sides you added, prove that they are equal. This is the question. Okay. Now please listen, a very, very easy one. Okay, but very important. Still now we were using only the one property of triangle. That is the tangent is perpendicular to the radius. The other property we were not using. Okay, this is where we are going to use. What is the other property? A point, if a point is outside the circle, if a point is outside the circle, we call it as the exterior point. From that point, you can draw two tangents and both the tangents are equal in length. As you can see here, B is outside the circle. From here, I've drawn two tangents. BR is a tangent, BQ is a tangent because it is touching at only one point, right? So BR and BQ are tangents. Both are equal because from an outer point, you can draw two tangents, both will be equal in length. Okay. So similarly for everything, D is a point outside. Therefore, I can tell DP equals DS. CP equals CQ. Similarly, we can conclude for everything. Okay. So let's start with EAR is equal to AS. EAR is equal to AS. Similarly, BR is equal to BQ. BR is equal to BQ. CP is equal to CQ. CP is equal to CQ. DP is equal to DS. Okay. What is the reason for all the four things that I have written? The reason for all this is lengths of tangents drawn from external point are equal. Okay, that is the reason. Here, what is ABCD? ABCD is a quadrilateral. Remember that. Okay. ABCD is this is given. ABCD is a quadrilateral. Is a quadrilateral. Okay. Now, this is what we have to prove. So, let's start with this LHS and try to get here RHS. Let's start from here and let's try to end here. Okay. Consider the LHS, that is AB plus CD. Consider the LHS, AB plus CD. Okay, that is equal to, from the figure, very clearly from the figure, I can write this AB as AR, this one, plus BR, isn't it? This plus this. AB can be written as AR plus BR. Similarly, CD can be written as CP DP, isn't it? CD can be written as CP plus DP from the figure. Okay. Now, just observe AR is equal to what? Just replace everything. AR is equal to AS, BR is equal to BQ, CP is equal to CQ, DP is equal to DS. Okay. Just from the above true result, we have taken it. Now, let's rearrange it. AS and DS. Rearrange it. I'll write this, then I'll write this. Then BQ plus CQ. Now, observe. AS plus DS from the figure. AS plus DS. This and this gives you the entire one AD. So, these two things gives you AD plus BQ plus CQ gives you BC. Observe, we started with LHS and we have ended at RHS. Implies AB plus CD is equal to AD plus BC. Hence proved. Okay. A very, very simple one, very simple question. What is it? We have to prove the sum of opposite sides are equal. So that's what we have done. How did we do it? Using the second property of tangent. Okay. Now, the 11th one, okay, this is the 8th question. The 11th one is almost the same thing. In the 8th one, they have mentioned this is a quadrilateral. But in 11th one, they have mentioned this is a parallelogram. So let me draw it like this. Okay, seems like a parallelogram now, almost like a parallelogram. Now, what is ABCD? ABCD is a parallelogram now. Okay, what should we prove? We need not prove this. We have to prove if this is a parallelogram, then it can also become a rhombus. To prove ABCD is a rhombus. What is a rhombus and what is a parallelogram? See, actually, rhombus is a type of a parallelogram. Okay, what is a parallelogram? Both the opposite sides are parallel. So AB and CD will be parallel, BC and AD will be parallel. Okay, and they'll be equal also. Now, what is a rhombus? Rhombus is also a parallelogram in which all the four sides are equal. In parallelogram, only the opposite sides are equal, but in rhombus, all the four sides are equal. So if I prove, see, it's a parallelogram, right? Therefore, I know the opposite side, AB and DC are equal, AD and BC are equal. I know that, right? ABCD is a parallelogram, which implies the opposite side, AB equals CD, AD equals BC. We know this, isn't it? Because opposite sides of a parallelogram are equal. So in a shortcut, I've written it as parallelogram. Okay. So this is equal to this. This is equal to this. Suppose if all the four sides become equal, if I prove all the four sides are equal, then it will become rhombus. That is all I have to prove. Okay. We're going to consider the same steps till here. Okay. The same way, whatever we did, the same thing we are going to do. Okay. From here, we'll make the changes. Okay. What are the changes? AB as it is plus CD can be written as what? AB. Observe. CD can be written as AB. Previous question, I cannot do that because it's a quadrilateral. In quadrilateral, opposite sides are not equal. Okay, but in parallelogram, opposite sides are equal. So instead of CD, I can write AB. AD plus, instead of BC, I can write AD again because opposite sides are equal. So what do you get? AB plus AB is 2AB. AD plus AD is 2AD. Therefore, 2 and 2 gets cancelled. You're left with what? AB equals AD. Okay. Now we have got what? AB equals AD. Now just observe. AB is equal to AD, but AD was already equal to BC, and this AB was already equal to CD. Isn't it? We have got this AB equals AD, but what was this AB equal to? CD already. AD was equal to BC already. Now observe what we have got. All the four sides are equal. If all the four sides are equal, what is ABCD? Rhombus. Implies ABCD is a rhombus. Why is it a rhombus? Because all the four sides are equal. If all the four sides are equal, then it is called as a rhombus. Okay. The same thing as 8th question, the same stuff till here. But here we have to change because the opposite sides are equal. Take out CD and BC, apply this. You'll get AB equals AD. Then you can do that. Okay. So if you prove all the four sides are equal, then it becomes a rhombus. This is 11th one. So we have done 8th one and 11th one at a time. Okay. Let's get into the next question, 9th question. In the figure 10.13, xy and x dash y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB is equal to 90 degrees. So the main thing that we have to prove is angle AOB. Angle AOB is this angle. So let me draw this one here. Okay. This angle is AOB. We have to prove it is equal to 90 degrees. That's what we have to prove. So let's do that. So first let's draw the figure. So we have got a circle with center O and we have got two parallel tangents and AB is also another tangent. Okay. Let's do it. So we have got a circle. Let's say this is question number 9, isn't it? So with center O, okay, let's take a diameter. PQ is the diameter because the tangents are parallel, right? Therefore PQ is the diameter. Okay, so one tangent is drawn here, another tangent is drawn here. Okay, let's take this as xy, let's take this as x dash y dash. Okay, and this is point P and point Q. Let me look into the figure again. XY. Okay, there is another tangent from A to B, something like this. Okay, join this O, A and B. The point where it touches, they have taken it as C. Okay, so this is the figure. What should we prove? We must prove that the angle AOB is equal to 90 degrees. Very a simple question. Let's make a small construction. What is the construction? Very simple. Just join O and C. Let me write O this side. Just join O and C. That's it. Okay. Now, there are 4 triangles here, smaller triangles. 1, 2, 3, 4. Let's concentrate only on them. Okay. First, let me take these 2 triangles. I'll just number the triangles. 1, 2, 3, 4. Let me take the triangle 1 and 2. That is POA and COA. In triangle POA and triangle COA, let's try to prove it is congruent. Very simple. Just observe. In this triangle 1 and triangle 2, you have to just try to prove it is congruent. In 1 and 2, OA is common, right? OA belongs to 1. OA also belongs to second triangle. So OA equals OA, common side. Very simple. Therefore, again, OP and OC. OP is also radius, OC is also radius. Radii of the same circle. OP equals OC, radii of same circle. Okay. The other one, since we have already proved the theorem, we'll take this. AP equals AC. A is a point outside. From that, you can draw 2 tangents. AP equals AC. AP equals AC. Tangents drawn from external point are equal. Tangents drawn from where? External point. External point are equal. Or you can do the same RHS theorem that we did while proving the result. The 2 tangents are equal. We proved the theorem, right? So same thing. Angle P is equal to angle C, 90 degrees. Then common side, OP equals OC. RHS theorem. You can do the same thing. Whichever, it's your wish. Choose whatever you wish. But you have to just prove these 2 triangles are congruent. We have just proved it. Therefore, triangle POA is congruent to triangle COA using SSS postulate. If 2 triangles are congruent, we know that the corresponding parts are equal. That is, you get this equal to this, isn't it? CPCT. Similarly, you get this is equal to this. I'm not interested in that. Let me consider only about this, which implies angle POA is equal to COA, that is CPCT, and I'll assume that these angles be X. Angle POA, COA is equal to X. So we got to know these 2 are equal because using the CPCT. Similarly, I can exactly the same way, I can show 3 and 4 are congruent. Similarly, triangle QOB, COB. QOB is congruent to triangle COB using SSS. Therefore, from CPCT, you get these 2 angles are equal. That is, COB and QOB are equal. Implies QOB is equal to COB, CPCT exactly the same way. Let me take this as Y. Let QOB is equal to COB equal to Y. Okay. Now, PQ is a diameter, right? It's a straight line. If I add all the angles, it will be equal to 180 degree. So, angle X plus Y is equal to 180 degree. Why? What is the reason? Angle on sum of angles on a straight line. Sum of angles on a straight line is 180 degree. If you add all the angles on a straight line, it will be equal to 180. So therefore, what do we get? X plus x is 2x, y plus y is 2y, equal to 180. So let me draw a root here. So x plus x is 2x, y plus y is 2y. I can take 2 as common. I will get x plus y is equal to 180. Send this 2 to the other side. X plus y is equal to 180 by 2, which implies x plus y is 90 degree. But from the figure, x, this is y, right? Both are equal to y. Both are equal to y. X plus y is nothing but this angle, right? This one. X plus y. X plus y is this angle. So which implies, what is the name of this angle? AOB. X plus y is nothing but angle AOB equals 90 degree. A very simple one. Take these two triangles, prove it is congruent. So you get these two as equal, x and x. Same stuff, you get y and y. Add everything, you get 180 degree. Therefore, x plus y is 90. X plus y is 90 implies AOB is 90. As simple as that. Okay. So let's get into the 10th question. Okay. So prove that angle between the two tangents drawn from external point to a circle is supplementary to the angle subtended by the line segment joining the points of the contact to the center. This is what I said earlier in one of the questions. A very, very simple one. So let's take a whiteboard itself, or let's do it here itself. It's a very simple one. Okay. Okay, let's take a circle with center O, and let's take an external point P. From this, you're drawing two tangents. Let's say it as PA and PB. So this is the angle between the tangents. Okay, let's take it as X, and the angle formed at the center by joining the point of contacts. The point of contact is A and B. Join it to the center, join it to the center. Here you got an angle formed, that is Y. We have to prove that X plus Y is 180 degree. To prove is X plus Y is 180 degree. Very, very easy question. What is the angle here? 90 degrees, radius and tangent. What is the angle here? 90 degrees, radius and tangent. It's a quadrilateral. If I add A plus X plus Y plus B, all the four angles, I get 360 degree because it's a quadrilateral. Okay, you have to write it in an order. I'm just explaining it. Okay, A and B is 90 and 90. So 90 plus 90 gives you 180. Send that 180 to other side. 360 minus 180. 360 minus 180 is what? 180. This is a simple one. There is nothing much to do it. Okay, so very simple. This is 90 and 90, so you get 180. It's very obvious. If you add these two, you should get 180 because the total is 360. Let's get into the 12th question. 11th one. That is why we are going to solve with the 10th one. Okay. So they have given us the figure. A triangle ABC is drawn to circumscribe. Again, observe. Circumscribe means what? The circle has to touch all the sides. Here it is triangle. So it is touching all the three sides. In the 8th question, it was quadrilateral. So it was touching all the four sides. So if it is touching all the sides of any triangle or quadrilateral, we say triangle is circumscribing the circle. Quadrilateral is circumscribing the circle, or pentagon is circumscribing the circle. In other words, this circle is called as inscribed circle. It is inside a polygon, right? So it is called inscribed circle. Okay. So triangle ABC is drawn to circumscribe the circle of radius 4 centimeter. Okay, the radius of the circle is given such that the segments BD and DC, into which BC is divided by the point of contact D. Okay, BC is divided into two parts, BD and DC. The length are given. BD is 8 centimeter, DC is 6 centimeter. We have to find the length of the sides AB and AC. Okay, that's the question. Okay, let's solve this. What have they given us? They've given us a triangle. Let's draw a circle. The radius of this circle is 4 centimeter, isn't it? So let's draw BC. You got B here, you got C here, and D here. Okay. So let me draw the triangle. Okay. Okay, it's coming here. Okay, roughly I've drawn a triangle. This is my A, this is D. This is 6 centimeter if I'm not wrong. And this is 8 centimeter. And the radius of the circle is 4 centimeter. Let's take O. Okay. This is the figure. Let's confirm it once. Yeah. A, B, C, D. Exactly correct. 8 centimeter and 6 centimeter. Okay. We have to find the value of AB and CD. Sorry, AB and AC. Isn't it? That's what we have to prove. Find. Okay. This is joined. Okay. Now, let's take this point of contact as some name. Let's take it as E and let's take it as F and let's join it. Okay. Let's join this. Okay. That is the construction. Along with that, let's also join this C with dotted lines. A with dotted lines and B with dotted lines. Okay. So let's start with construction. We know what we have to find out, isn't it? AB and AC should be found. Okay. Construction. So in this construction, what did we do? Join O and E, join OE, OF, OA, OB, OC. These are the things that we did. Okay. Now please observe carefully. C is a point outside the circle. Very clearly it is outside the circle. From outside you can draw two tangents. Both the tangents will be equal. Therefore, if this is 6, this will also become 6 centimeters. Same stuff. If this is 8, this will also become 8 centimeters. So we got it. Okay, what are the two things that we got? CE is equal to CD. Similarly, BF is equal to BD, because the length of tangents drawn from external point are equal. Similarly, the same logic, AE will be equal to AF, isn't it? The same logic, AE will be equal to AF. Let us assume it as some x. AE and AF both will be equal to some value x. Okay. Because A is a point outside, from there you can draw two tangents. So this is x. If this is x, this will also become x. Isn't it? Okay. Now, very simple. If I find the value of x, the problem is done, because I know this x. Add with this, I get the complete value of AC. Same thing for AB. So the main motivation is to find x. Okay. Okay. Now, let's start. You would have learned something called as Heron's formula in the last academic year. Okay. Heron's formula is used to calculate the area of the triangle. So area of the bigger triangle, area of triangle ABC. It is given by square root of S into S minus A into S minus B into S minus C. A, B, C are the sides of the triangle. Okay. And S is the semi-perimeter. S is equal to A plus B plus C divided by 2. Semi-perimeter. Half of perimeter. Okay. What is A? A is the sides of the triangle. AB. Let's take A as AB, B as BC, C as CD. Sorry. C as AC. What is the value of AB? The value of AB is x plus 8. And what is the value of BC? BC is 8 plus 6 is 14. And value of AC is x plus 6. These are the three sides of the triangle. Isn't it? This complete side, this is x and this is 6. Total will be x plus 6. That is your A, B, C. Okay. Now, how do you find semi-perimeter? S is equal to A plus B plus C divided by 2. Okay, what is A? X plus 8. What is B? 14. What is C? X plus 6 divided by 2. If you observe here properly, x plus x is 2x plus 14 plus 8 is 22. 22 plus 6 is 28 divided by 2. So you get 2x plus 28 by 2. You can take 2 as common. So you'll be left with x plus 14 by 2. 2 gets cancelled. Okay. Therefore, the value of S Therefore, S is x plus 14. So you got the value of S, substitute here. Root of, what is S value? X plus 14 into, what is S value again? X plus 14 minus, what is A value? X plus 8. There are two things, so let's put a bracket. Okay. Similarly, S minus B. What is S? X plus 14 minus B is 14. Similarly, now we have to do S minus C. I don't have space, so let me write it here. X plus 14 is S minus X plus 6 is our C. Isn't it? I don't have space, so I've written it like that. But you have to write it in one straight line. Okay. So let me erase the top part and continue. So let's continue from here. Okay. So what we have got, area of triangle ABC is equal to square root of x plus 14 into x plus 14. Remove this bracket, minus into x, minus into plus 8 is minus 8. Plus 14 minus 14 gets cancelled. You will be left with x. Then this one, x plus 14, remove the bracket, minus x, minus 6. Okay. If you observe, plus x minus x gets cancelled, plus x minus x gets cancelled. What you're left with is x plus 14. Here 14. Here you got x. Here also you got 14. Okay. Those are the things. I'm sorry. 14 minus 8, right? 14 minus 8 is 6. Here 14 minus 6 is 8. So 6 8 is 48. So it becomes root of 48x into x plus 14. Okay. Let's keep this as it is. Let's keep this as it is. So what did we do? We found the area of the triangle ABC using Heron's formula. Okay. That is all we did. Okay. Now what let's do is, let me erase this quickly. Now please listen carefully. Okay, let's consider as equation 1. Okay, area of triangle ABC. Just observe the figure. Can I write area of triangle ABC as, just observe, this entire triangle, I'll write it as sum of three things. That is this triangle, this dotted line. Just observe that I'm tracing. This triangle plus this triangle, the left side, the right side, and the bottom one. If I add all these triangles, I'll get back ABC itself, right? So area of triangle AOC plus area of triangle BOC plus area of triangle AOB. Isn't it? This entire thing can be written as sum of these three things. Now area of triangle ABC, just now we have found it as root of 48x into x plus 14. Let's substitute it. Now how do you find area of a triangle? Half into base into height. Half into base. For this triangle AOC, I'll take AC as the base. If AC is the base, OE acts as the height. Because you can take any side as the base. The perpendicular line acts as the height, isn't it? So this is the base. This is acting as height because here the angle is 90 degree. Because this is tangent, this is radius. Angle between radius and tangent is 90 degree. So OE is your height of this triangle. Similarly, half in BC triangle, BC is the base, OD is the height. Similarly, half in ABC triangle, AB is the base. You can guess it, OF is the height. Isn't it? Therefore, root of 48x into x plus 14 equals half. AC value is x plus 6. OE value, OE is radius, so I can take it as 4 because the radius of the circle is given as 4. Half BC value is 14 into OD value is 4 plus half AB value is x plus 8 into OF is 4. So let's cancel it. 2 1s are, 2 2s are, 2 1s are, 2 7s are. 2 ones are 2 twos are. So what are you left with? Root of 48x into x plus 14 equals, what do you get here? 2 times x plus 6 plus 7 into 4, 28 plus everything gets cancelled, 2 into x plus 8. Isn't it? So now root of 48x into x plus 14 equals 2 into x, 2x, 2 6 are 12, 28, 2 into x, 2x plus 16. Okay, so let me again erase it and write it at the top. So let me erase this stuff and continue. So what are we left with in LHS? Root of 48x into x plus 14 equals 2x plus 2x is 4x. Then what do we get? 28 plus 12, 40. 40 plus 16 is 56. So we get 56. So I can write this as root of 48x, x plus 14. I can write this as, take 4 common, I can write this as 4 times x plus 14. Okay, squaring on both sides. Squaring on both sides, what do you get? If you square it, square and root gets cancelled. You will be left with 48x into x plus 14. Here you will be left with 4 into x plus 14, the whole square. This is what you will be left with. Now, let's continue. Okay. The last step. Once you get the x value, you can easily find everything. Okay. Now, if you observe 48x into x plus 14, I can split the square. Since they are in multiplication, split the square. 4 square, x plus 14, the whole square. Okay. Now, very simple. This 4 square, 48x into x plus 14 equals 16 into x plus 14, the whole square. X plus 14 one times, x plus 14 one times, or you just send this x plus 14, which is in multiplication, to the other side. So one time it gets cancelled. Okay. So now what are you left with? You're left with 48x this side, and this side 16 into x plus 14 one times. Send this 16 the other side. So it will become 48x by 16 equals x plus 14. 16 ones are, 16 threes are. So it will become 3x. So 3x is equal to x plus 14. 3x is equal to x plus 14. Therefore, 3x minus x is equal to 14, which implies 2x is equal to 14. Therefore, x is 7. You got the value of x as 7. Once you get the value of x, now you can substitute. X is 7. 7 plus 6, 13. AC is 13. 7 plus 8, 14. So this is 14 and this is 13 centimeters. Sorry, this is 15. 7 plus 8 is 15. I'm sorry. So this is 15 and this is 13 centimeters. Okay. So in shortcut, I mean, what can I say is, first we found the area of the bigger triangle using Heron's formula. Then that bigger triangle can be written as sum of 3 triangles. Using that, we got the value of x. Okay. Let's get into the last question of this exercise. That the opposite sides of a quadrilateral circumscribing a circle. So we know what is quadrilateral circumscribing a circle. We should have a quadrilateral. Inside that quadrilateral, we should have a circle which should touch all the 4 sides. Isn't it? 8th question and 11th question were similar to it. So they prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay. So let's take first step. Let's draw a circle. Okay. With center O. And let's take a quadrilateral circumscribing the circle. Something like this. Okay. Let me take like this. Okay. Okay. A, B, C, D. The point where they touch, let me take it as P, Q, R, S. Okay. This is quadrilateral circumscribing a circle. What we have to prove? Prove that sum of the angles. Where are these angles formed? At the center. By what? By the opposite sides. Meaning, if you join this end of the side to the center like this, you get an angle. Similarly, the opposite side, take the ends and join it, you get an angle. We have to prove that these angles are supplementary. Okay, if I add this and this, I get 180 degree, or in other words, this and this 180 degree. Okay, so to prove is angle AOB plus angle COD equals 180 degree. Okay, let me make a small construction. What is the construction? Join OP, OQ, OR, OS. Okay, join OP, OQ, OR and OS. Okay, and the angles are numbered. Okay, and numbering the angles. So that is, I'll take this as 1, 2, 3, 4, 5, 6, 7, 8. Okay, let me erase this for time being. Okay, this is angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. You can see there are 8 angles. Okay, now what I'm going to do is just observe. I'll take these two triangles where 2 and 3 are there, these two triangles, and I can prove that they're congruent. We have already done exactly the same type. OB is the common side, OQ is equal to OR, radius of the same circle, BR is equal to BQ, tangents drawn from external point are equal. Therefore, these two triangles are congruent using SSS. Let me write that. In triangle RBO and triangle BQO. So OB is equal to OB, common side, isn't it? Then what do we get? OR is equal to OQ, radii of same circle, radii of same circle. Then BR is equal to BQ. Tangents drawn from external point are equal. Tangents drawn from where? From external points. Tangents drawn from external points are equal. Okay, therefore triangle RBO is congruent to triangle BQO using SSS postulate. They are congruent using SSS postulate. Okay. Therefore, if they are congruent, from CPCT I can tell angle 2 is equal to angle 3, which implies angle 2 is equal to angle 3 CPCT. Similarly, you can say these two triangles are congruent. Sorry, these two, 4 and 5. Okay, these two, 4 and 5 are equal. The same way, 4 and 5 are equal, 6 and 7 are equal, 8 and 1 are equal. Okay, you can say that. Okay, now we know that if I add all the angles 4, 5, 6, 7, 8, it will be equal to 360 degree, because around a point, the complete angle around a point is 360. In this, if you observe, okay, I want AOB. AOB is nothing but this angle, right? This is AOB. That is 1 and 2. 6 and 5 is COD. I need 1 and 2, 6 and 5. Keep those things, change other things. Keep 1 and 2. You need 1 and 2, and you need 6 and 5. Other things you change it. 3 can be written as what? 2. 4 can be written as what? 5. Okay. 5 and 6 we need it, so we'll keep it as it is. 7 is equal to what? 7 is equal to 6, and 8 is equal to 1, equal to 360. Whichever is required, we have kept it. The other things we have changed it. Okay. How many times you got angle 1? 2 times angle 1, 2 times angle 2. Similarly, 2 times angle 5, 2 times angle 6, equal to 360 degree. Everything got 2 times. Take 2 common. You will be left with angle 1 plus angle 2 plus angle 5 plus angle 6 equal to 360. Now, if 2 is common, if you send it the other side, it will become 360 by 2, which is 180. So next step, Angle 1 plus angle 2, angle 1 plus angle 2 is what? AOB. Angle 5 plus angle 6 is what? COD. 360 by 2 is 180 degrees. Okay. Very simple. You prove these two triangles are congruent. Same stuff. All the two triangles. You cannot prove these two triangles as congruent. Remember that. This is common side. Only you get this. These two are, so you have to be very careful in choosing the triangles. These two. Okay, it will be like a square. If you observe, it will be like a square. Okay. Prove these two are congruent. You get 2 is equal to 3, 4 is equal to 5, 6 is equal to 7, 8 is equal to 1. Then if you add everything, 360. Then which are the things that you need? 1, 2, 6, 5. Keep those. 1, 2, 6, 5. Keep this. Other things. 3, 4, 7, 8. You change it. 3 is 2, 4 is 5, 7 is 6, 8 is 1. Change it. Okay. Change it and group it. You'll get the answer. Okay. So this is the answer for the last question. I hope you guys have understood. So in this chapter, the very important thing is what is a tangent? Then the properties of tangent, two important properties. If you practice these things well and the problems in the textbook, it's more than enough for your exams. Okay, students, thank you.